My name is Susan Solar. I lead the Digital Insight Labs team, and this is part 3 of my talk on what's shaping the future, power platform and paradigm shifts. In part 1, I looked at countries and people. In part 2, I talked about fintech trends. In this part, I'm going to look at applications of artificial intelligence, quantum computing, and VR, AR, and mixed reality. I cover blockchain in a separate talk and will not be including it here. I want to say one more time up front that I'm going to do a lousy job of recognizing the many sources I pulled from to create this talk. If I were to give credit where it's due, my slides would be covered in footnotes, but if you search on any of these sources of articles, podcasts, and videos, you'll find the topics, the ideas, the research reports, and the stories I cover, and the incredible people who created them in the first place. Okay, jumping in. First, a nod to the AI hype cycle. A lot has been said when it comes to AI anxiety, and specifically general AI, or artificial general intelligence, the idea that AI will eventually reign over us. Sophia, pictured here, was even legitimized as a citizen of Saudi Arabia as a publicity maneuver in 2017. I'm going to focus on practical and amazing applications of AI. There are a lot of ways of characterizing artificial intelligence or machine learning. One example is by how an algorithm learns. Is it supervised, unsupervised, or is it reinforcement learning? Typically, a combination of machine learning algorithms are applied to get the best result for a particular problem. The same machine learning techniques can be applied across a broad set of applications. Here I'm going to organize AI loosely into categories of what we know it can do well today. Not too long ago, it became possible, technically and economically feasible, to do computationally intensive machine learning at scale. Specialized computational horsepower like GPUs, now TPUs, low-cost hardware, open source tools, and frameworks opened up the possibilities of deep learning, for example, which is one type of machine learning that is great when applied to recognizing images, language, behavior patterns, and a lot more. Being able to recognize something for what it is informs all kinds of decision making, whether it's risk assessment, like Earnest does for underwriting loans for students who don't have a credit history, like I talked about in part 2, or medical records analyzed to detect the potential for disease. Or another example is Axon. They created Taser. They're busy transforming police work by collecting video from police body cameras and applying AI to process and analyze it for evidence. In fact, half the police departments in the United States use Axon's body cameras already. Prediction is closely related to recognition, predicting outcomes or preference or needs based on past behaviors. In part 2, I talked about Robinhood making stock purchase recommendations based on consumer online shopping experience. The people who bought this also bought approach. Spotify is another example. Looks not just at your taste in music, but what mood you might be in, based on the time of day and the activity you are doing, whether you're exercising or sitting in front of a computer trying to get your work done. The Chicago police have also been doing predictive policing, essentially interventions visiting people who are potentially on the path to commit a crime. Action. This is where I put assistance of all kinds, whether it's voice or digital, whether it's personal financial bots trying to help you make good decisions with your money, travel bots to help you book and change your travel plans, host bots for Airbnb hosts, particularly those who own a lot of properties and have to handle a lot of questions from renters. And there are lots of hospitality bots in the works to replace everything from drive-through ordering to what happens at a concession stand at a stadium. Automation is about self-operating environments, whether it's financial automation, agents that manage your finances over your lifetime in your best interest, or autonomous cars or lights-out warehouses that Amazon and Target have been working on. And finally, AI that can create, can discover something new, design and invent something on its own. Design patents have already been filed for AI-designed space antennas that are twice as effective as human-designed antennas, and metalwork that's lighter and stronger than what we've been able to come with, and so much more. In the next few slides, I'm spotlighting interesting examples from some of these application areas. I like this example because it shows how data about human behavior can be used to influence how our environment and infrastructure, roads, pedestrian walkways, are designed. I use Strava every day on my run. Strava tracks and analyzes my movement along with millions of other users and makes that available so that there are 125 organizations around the world using it for urban and suburban planning purposes. In part 1, we looked at China's growing power and broad presence. What started all this growth was the move overseas for cheap labor. Meanwhile, China's average wage per year has doubled in the last 7 years, and companies in the US are looking at automation as a way to bring down costs on American soil. China is in the automation race, trying to keep its appeal and economic power. This is a picture of a lights-out, fully automated factory. With robotics and AI-driven automation, you can turn off the lights and reduce electricity costs. You can pack warehouses more densely and get more per square foot. There's no worker turnover, no worker shortage, or employee overhead. Right now, this is still a high-cost model, but the expectation is that those costs will come down. Creation, design, invention. What can AI do here? One approach is various forms of evolutionary computation which focus on creating solutions that do not exist yet. Sentient is one company that does this. Here's a simple example of their website. When I visited, I was vaguely put off by the colors. These are not colors I would pick. And then I looked at the call to action button, schedule a demo for NCR, and I thought, I'm not at work, I'm at home, I'm not on VPN. I've never visited this site before, and I realized what I was looking at was a color scheme and a call to action created by AI to maximize the chances that I would click on that button. The color contrast made me notice the button. The text on the button was clearly talking to me and said, I know who you work for. Let's look at an agricultural example. Growing basil. Basil is grown in staggered batches, and artificial intelligence can use the data from each batch to suggest changes to the climate recipe for the next crop even before the first crop is finished growing, increasing experimental throughput. Next, researchers asked the algorithms to optimize for flavor, create an environment that would maximize the specific molecules that create the best flavor for basil. First, the algorithms rediscovered a known trade-off that the bigger the plant and the leaves, the less flavorful it is. But it also discovered something that surprised everyone. There was a belief that basil needed a natural rest cycle, basically nighttime to sleep, like we do. AI discovered that by keeping the lights on continuously, there was an increase of between 700 and 900% of the various molecules that maximize flavor. There are also a lot of considerations now being given to data privacy in AI. One approach is to separate personally identifiable data and keep it at the edge computing node, and only share anonymized data that's analyzed for aggregate insights at some centralized point. One example is an experiment that used Microsoft Xamarin to protect patient privacy. A patient could use the camera on their phone and an app to look at moles and assess the risk of skin cancer. Any data collected about the patient would remain resident on the phone. Another example is what Mercedes-Benz is doing. As you drive the newest Mercedes, it's continuously collecting all kinds of information about you. Your personal data, however, stays in the car. Only anonymized data is sent back to Mercedes headquarters. And all the real-time personalization and interaction with you is computed and generated in the car. This was just a small sample of the many applications of AI across industries. AI will be infused in just about everything down the road, and it won't just be algorithms running at a centralized location for a business. It'll be native to the technology it's serving. Think about a mango. Today in the United States, what we eat is a large, flavorless mango that came to the US thanks to the adventures of this guy, David Fairchild. The mango we eat today, the Tommy Atkins, is the one hardy specimen that happened to survive as a cutting. But if you go somewhere equatorial or somewhere expensive, like a Harrods, you will taste mangoes that will just blow your mind. I mean, the flavor will be like nothing you've eaten before. So, why is this? Meanwhile, 40% of the mangoes grown in the US for consumption go to waste because they have yellow skin, and Americans can see bruising and associate lower quality of mango. This was a small sample of the many applications of AI across industries. AI will be infused in just about everything down the road, and it won't just be algorithms running at a centralized location for a business. It'll be native to the technology it's serving. Think about a mango. Today in the United States, what we eat is a large flavorless mango that came to the US thanks to the adventures of this guy, David Fairchild. The mango we eat today, the Tommy Atkins, is the hardy specimen that happened to survive as a cutting. But if you go somewhere equatorial or somewhere expensive, like Harrods, you'll taste mangoes like you've never tasted before. Meanwhile, 40% of the mangoes grown for U.S. consumption go to waste because they have yellow skin, and Americans equate bruising with lesser quality, and you can see bruising easily on yellow skin mangoes. Now there are people working on how to grow delicious mangoes in our climate that also have purple skin because we like purple and because it doesn't show bruises. AI will help figure out the growing conditions for the flavor and climate, and can even help figure out the right skin color. Next, we plant our mangoes, and in a few years we have hundreds of acres of mango trees. We use AI to predict, based on the temperature and weather, when we need to harvest and about how much fruit we can expect. AI running on satellite images of our farm may detect that some of the tree leaves are turning brown. A drone goes in for a closer look and identifies a pest that's quickly spreading. We can use AI to start to breed trees that are pest resistant. At the same time, we use AI to determine the best pest treatment. We use AI and robotic pickers to delicately pick the mangoes. Right, that is a pepper, but you get the idea. Because there aren't enough people available to harvest all mangoes we need to grow to satisfy demand. We harvest the mangoes, and off it goes into the food supply chain. The supply chain runs on blockchain, so the entire path of the mango, from field to factory, where it's cleaned, pitted, sliced, and put into bags and transported to a Walmart, is tracked. All along the journey, conditions and travel routes are optimized by AI to get that mango to the store the most efficiently and at its freshest state. You took the mango off the shelf, and because you lingered, AI determined that you're more likely to put it in your cart if you get a notification that your first bag of mangoes is 50% off. They know you haven't bought these mangoes before. In fact, they know you came a week ago and stared at the mango and put it back. You put the mango in your cart and you walk out of Walmart. AI identified who you were, what you bought, and charged it to you automatically without you checking out. You took the mango home, ate most of it, but the last few pieces stayed in the bag too long and rotted. You threw those pieces in the compost and the plastic bag in the recycling. And from here, the compost and the recycling take their own AI-infused journey to their final resting place or reincarnation. Today, there are a lot of ways AI can get it wrong or show bias, and we need to pay attention. We can get it wrong in lots of ways. By how we goal and reward an algorithm. YouTube is an example where the goal is to maximize the amount of time you keep watching YouTube, which has not much to do with your specific interests or what's good for you. It can also be that as an algorithm learns, it weighs the importance of certain things wrong and goes down the wrong learning path. What data we include or omit, maybe because we don't have it. Machine learning can only look for reasons, correlations, and attributions for why something happens from the data it has, and how we treat missing data can also lead to the wrong result. Filling in zeros for missing data is an obvious example. Feature extraction, how we transform data to represent what it's doing. This often requires domain expertise and is as much an art as a science. How we try to coalesce data into categories or averages or other representations before we apply machine learning, or when we try to smooth out the data. My favorite example is that for years, signals that there was a 12-mile saltwater lake under the south polar region of Mars were missed because, in order to reduce the size of the large data streams from the spacecraft, the onboarding computer was sending back averages across pixels, smoothing out the anomaly that was the lake. Another way we can get it wrong is a machine learning algorithm may try to overfit or to a lesser extent underfit the data, which means there's either too much noise in the trend or the algorithm can't find a trend. Both lead to poor prediction models. Bias has been getting a lot of attention, especially since the 2016 election. As a result, Google created What If to explore model results, and IBM just introduced a few days ago a new set of trust and transparency capabilities for AI on IBM Cloud. For example, checking for bias each time the algorithm runs, and Microsoft and Facebook have plans to roll out anti-bias tools as well. In the classical world of computing that we live in today, an enormous amount of progress has been made with GPUs and TPUs in terms of specialized computational power. GPUs were developed for gaming but turned out to be great for AI, and now TPUs are promising to be even better. But transistors work on ones and zeros, and performance improvement is on a linear scale. Quantum computing is completely different. It relies on quantum mechanics, superposition and entanglement to perform operations on data. If a classical bit can be a 1 or a 0, a qubit can have many states, so the potential increase in speed is no longer linear, but it's not as straightforward as saying it's exponential. And because quantum entanglement is a fragile state, a small interference can cause quantum decoherence, so error correction is a big part of the work being done today. Quantum supremacy is considered to be the point where we can solve problems with quantum computing that could not be solved before. This is thought to happen at around 52 qubits. What exactly can a qubit in a real quantum computer be? Well, it can be an electron with spin, a photon with polarization, impurity spins, trapped ions, neutral atoms, semiconducting circuits, or in the case of Microsoft, based on a particle that is yet to be proven to exist. D-Wave was one of the first using annealing, which is good for specialized problem sets having to do with optimization. So where is quantum computing today? It's at a point where we can say it's going to be a reality in maybe 10 years. It's also at the mainframe stage. New algorithms need to be created, new software stacks built, decoherence needs to be dealt with, but it's real. Even traditional institutions like banking are taking it seriously. Commonwealth Bank in Australia, for example, has had a quantum simulator deployed since 2017. And you can see that not just the biggest companies, but the largest governments in the world are involved in developing quantum computing. So what is it good at? One of the first things quantum computing is expected to crack is encryption. Why is it hard to break now? To crack RSA, you have to have two prime numbers that are a factor of a 1024-bit encryption key. If you're trying to remember what a prime number is right about now, that's a number that can only be divided by itself and 1. So it's a simple computation, and it could take a computer forever to compute that without quantum computers. There are already people working on quantum-resistant encryption. Some of the most interesting applications of quantum computing are optimization type problems. So I'm going to talk about a few examples. Drug discovery. Today, it takes pharmaceutical companies up to 10 years and often billions of dollars to discover a new drug and bring it to market. The early phase of drug discovery is called molecular matching. This takes a long time with a classical computer and is pretty limited to small molecules. With quantum computers, scientists can see what molecules bond to what structures, where and why at a vast scale and with great precision. It makes drug discovery faster, and the ability to repurpose pre-approved drugs for new applications and create individualized treatments based on a patient's DNA much more feasible. Today, both recommendations and weather are a patchwork of partial information pieced together to make a best guess. Weather maps are either detailed but limited to a small area, or covering a large area with macro trends. With quantum computers, all the data can be analyzed at once, creating a far more accurate, detailed weather map globally, which should improve forecasting, climate change predictions, and is even expected to factor into how insurance is structured and priced. The recommendations that you get on Netflix is based on partial data about you and everyone else mapped into a matrix, and a classical algorithm has to look at a lot of memory to generate a recommendation. One of the early real-world applications identified for quantum computing was a quantum algorithm for recommendations that had to make far fewer queries to memory because it can hold so many more states. This is an interesting story because the quantum algorithm was developed first to show the advantage over classical computing, but this last June of 2018, an 18-year-old boy, Yuan Tang, proved that a classical algorithm inspired by the quantum algorithm could achieve the same thing. Now about simulation. I was listening to a talk by someone who worked at Uber on the driverless car, and he talked about the hundreds of hours spent in the car when nothing happened, that 98% of the time the data is boring. You can't train a car to handle an edge case that doesn't occur. People don't usually jump in front of cars. This is where simulation is important. With simulation, you can test on billions of miles of custom scenarios and rare corner cases, all in the fraction of the time and cost that it would take to do so on real roads. Testing and validation is incredibly important for safety and reliability. Think about it. Every time software is updated, the code needs to be tested to verify that nothing else broke. Ford and Volkswagen are already looking at this. Volkswagen is using quantum computing to improve reinforcement learning techniques for software agents that control the car to learn about interacting with their environment. For example, in the case of automated parking. Another high potential application area is also a type of optimization, logistics problems. This is a picture of the worst ever traffic jam. The China National Highway traffic jam, which was 60 miles long and lasted 2 weeks. Volkswagen decided to tackle Beijing traffic as one of the first problems for quantum computing. Working with D-Wave's quantum annealing computer, they were able to calculate an individual's optimal rerouting for each car that also takes into consideration the path of the other cars in the city. The idea is that with quantum computing in the future, optimal routes can be calculated simultaneously for every car on the road, avoiding the traffic jam in the first place. There could be optimizations on other factors, like how to consume the least gas across vehicles or the least electricity. Which brings me back to another example of molecular discovery. Volkswagen is also applying quantum computing to the problem of battery life. Batteries are the biggest cost in electric vehicles, and Volkswagen is simulating molecules to help develop new batteries that can last longer. That's a quick overview of some possible applications of quantum computing. If quantum computing isn't mind-bending enough, let's look at the mind-warping possibilities with VR, AR, and mixed reality. I'm going to call it XR to not have to repeat all three variations in every sentence. If you're not convinced that XR will ever become an everyday reality, here are a few points to start us off on this journey. Facebook was late to mobile and had to pivot to catch up, and as a result, doesn't own the OS on any platform today like a WeChat or an Alipay does in China. Mark Xi is convinced, like many tech leaders, that XR will be the next consumer platform, and you can see this by the hiring chart from last October, that Oculus was a big chunk of the hiring pie. Facebook also released the low-cost, high-quality Oculus Go earlier this year at a $199 price point. XR is everywhere. AR is native to the latest iOS. The Vive, the Oculus, and many other devices have been on the market, improving quality and coming down in cost. And new entrants at the very top of the market are coming out as well, like Varjo from Finland, with the ability to create real-time VR MR at the resolution of reality, so what you would see with your eyes in the real world. Companies like Varjo are focused on enterprise applications because 66% of XR sales are expected to be to businesses. AR and VR markets combined will grow to $71 billion in sales by 2021, up from $6 billion this year, so the expectations are high. What is real? This image serves dual purposes. It taps into a core belief that we subscribe to in labs, using empathy and observation to come up with simple solutions to problems. It also demonstrates how easy it is to mess with our perceptions. So in this TED Talk, Malaya found a simple, elegant solution for her uncle's Parkinson's disease. Her uncle could barely walk with a walker on a flat surface, but he was a pro at walking stairs because walking stairs is a continuous motion. She created a long print of a staircase, and the moment her uncle came up to it, he was able to walk across the flat surface easily while carrying his walker, which is what you see in that center picture there. You may remember this story from a few years ago. Over 30 million people saw the picture of this dress, and 2/3 of them saw a white and gold dress. A third of them saw black and blue. It's actually black and blue. It turns out this is because when our brain has incomplete information or uncertainty, it fills in the gaps. Here's another example. 14% of people think cilantro tastes like soap. This turns out to be a result of our genes. So whether it's in our genes or our brains make assumptions to fill in missing information, our perceptions of the same thing can be wildly different, and therefore our perception of reality can be wildly different. Let's go one step further looking at perception as reality. In Japan, there's an industry built on renting family members and renting friends. The reasons can range from saving face to comfort. You can rent spouses and enact weddings, or hire an actor to fill in for an absentee parent, or pretty much for any type of relationship that's expected or missing. The line between what is real and what is fake is blurred. Now imagine filling in that missing person or that missing life in XR. Meitu is an app that's been downloaded more than 1.1 billion times, used mostly in China to edit selfies, changing yourself into someone with big eyes and other desirable features. And now there's a plastic surgery industry that will change your face to look like your Meitu self. Cameras and phones have become increasingly powerful with the latest iPhone, and beyond the iPhone, cameras like Light, a 16-lens multi-sensor device that fits in your pocket, taking computational photography to the next level. So there are already many ways we're altering our real life and our real selves. And now let's step into the virtual world. As the image quality of XR gets clearer, the line between what is real and what isn't is getting blurrier. In Florida, Google's Magic Leap is perfecting MR, the promise of which is both practical, like moving away from flat-pane browser rendering of the internet, and magical, like holding a tiny elephant in your hand. And for the more far-out-there dreamers, Elon Musk's Neuralink is working on implantable brain-computer interfaces. What's different about XR is how easily they play with our perceptions. If you stood in line for 3 to 6 hours at Disney World, Florida for the Avatar Rite of Passage, you experienced that pretty mind-blowing immersive experience built with technology that's already more than a year old. VR has gotten better and cheaper since then. So what's the difference between these types of realities? VR is fully immersive in another world. If you're in VR moving around, you'll run into your furniture. Augmented reality is along the lines of Pokemon Go, a layer on top of the real world but not aware of it. You can see both, but only you can avoid running into your furniture. And mixed reality is when content is placed in the real world such that it's aware of the real world objects and can interact with them, so you both can avoid running into your furniture. Another aspect of VR, especially in a multi-person experience, is that in a controlled, immersive environment, you're present and undistracted. Unlike in the real world, where we're all looking at our little screens, not looking at each other, and not looking out the window at the view. Applications of XR cross industries and disciplines. Here I've organized them into application types on a spectrum from the familiar and pragmatic to areas that reach into unknown and uncomfortable spaces. Applications may incorporate more than one of these approaches. Here I'm going to give examples that take advantage of a particular benefit. A multidimensional or sensory experience can augment 3D modeling across many disciplines: architecture, medicine, chemistry, and data science, for example. This is a 2D rendering of words Googled around Christmas time that is a lot easier to decipher in 3D. Visualization in 3D can give you a deeper understanding of how things work and fit together. Environmental applications augment training or providing a service. I live down the road from Striver, a startup focused on training to improve the performance of employees and athletes. Last year at Finovate Spring, one of the use cases my NCR friends and I demonstrated was the ability to service an ATM remotely via virtual reality without sending a service agent on site. Later at the conference, a woman from a large financial institution told me they have 2 ATMs in Antarctica they could use this for. Experiential is the area that has paved the way for VR, starting with gaming and movies like Avatar, extending into tourism, bringing ancient worlds to life like the Greek or Roman ruins across Europe, or bringing remote parts of the world to you in your living. It can also be applied to train AI based on human behavior. For example, to train AI to calibrate a gaming experience to your level of competence, or to train it for real-world reactions to edge cases, what an autonomous vehicle should or shouldn't do if another vehicle rams into it, for example. And finally, we start to get into the unknown and possibly uncomfortable interference with our own reality in controlled lab environments focused on good outcomes like pain management or emotional therapy, for example. In Barcelona, the European Union VR team is working on embodiment and illusion of presence VR-based therapy for phobias, PTSD, and rehabilitating prisoners, where you are put in the other person's shoes. You experience yourself through the eyes of someone else. I'll spotlight a few more examples next. Here are some examples of how adding a dimension and sensory feedback makes all the difference. First, we have Dr. Burke, a cardiovascular surgeon in Miami. He used image scans from this baby's heart and some software to create a 3D image that he could view on his smartphone using a Google Cardboard. He was able to turn and explore her heart in detail to prepare for the surgery that saved her life. This other one is one of my favorite examples of how XR can reveal what we can't see in the real world and what we can't easily decipher in 2D. In school, we learn about molecules from drawings like these. Only a few of us will ever understand and fall in love with chemistry from this. In VR, not only can you see the structure as it exists in 3 dimensions, you can also see how a molecule behaves. Molecules aren't rigid structures, and in this example, you see a molecule being tied into a knot. You can see how molecules fit together, how they stretch, or how elastic and inelastic they are. One final example about the experiential. One of the first apps you'll experience on any VR device is riding a roller coaster. In this example, the Wall Street Journal took the Nasdaq's ups and downs and turned it into a ride. What I love about this is that it inspires the question, how can we experience data, evoke feeling to convey what it means, and to leave an impression? One last story, now weaving together AI and VR. Today, NFL players wear RFID chips in each shoulder pad, tracking and analyzing their positions throughout the game. Their helmets are loaded with sensors to detect, manage, and prevent brain injuries. In fact, they have sensors all over their bodies monitoring to predict performance and potential for injuries. Most NFL teams and college football teams and rugby teams and many other teams now use these mobile virtual players to practice tackling and minimize injuries. There are also robots in development to automate umpiring and refereeing to reduce human error, applying AI to real-time streaming video analysis. And today, professional athletes prepare for the next game by entering their last game via virtual reality, reliving and learning from their past performance to improve for the next. That wraps up the tech shaping the future focus of this talk. All the tech in this talk would not be where it is today without the internet. The internet is still predominantly a bunch of cables shuttling ones and zeros around the world. There are 448 cables running the internet across our oceans, or over 746,000 miles of cable running across the ocean floor, connecting all of us together. Demand for international bandwidth is growing by 45% a year. Most of the new cables are owned by Google, Microsoft, Facebook, and Amazon. That in itself is something to think about. So, How much of the world's electricity does the internet consume? 8%. We talked about the rapid growth of streaming content in part 1. How much of the internet consumption is from streaming? 65%. How much of the internet bandwidth is Netflix using? 15%. The internet looks and functions more and more like the human central nervous system every day. One final number. What percent of carbon emissions are from the internet? 3%. Right, I did say in the beginning that I would not talk about global warming. I'm just putting this number here as a marker of time. If we consider the start of the internet as the invention of the World Wide Web in 1990, then in 28 years, we've gone from 0 to 3%. And to wrap things up, a quiz. What is 200,000 times more efficient than a transistor? Hint, you have 86 billion of these. A neuron. What's cheaper and more fun to make than a computer? Packaged in a highly portable framework? A human brain. We have the most amazing machine inside us. This talk was about what are some of the things shaping the future, but the fact is that it's shaped by human minds and hands. When you work with emerging technology, you realize it's still hard work to get the stuff to work and to get it to work together. Under the hood, it's human thought and intuition and problem solving that makes the difference for better or worse. The future is going to come at variable speeds, no matter what. And we can save and harm humans at a scale that's never been possible before. It's in our hands to make technology do and be good. The end.